Hello, welcome to the next video, video 8 in atomic physics, detecting nuclear radiation. Now this one is pretty much a recap of what you would have learnt in physical science, hopefully. So you may have forgotten it, but we'll just quickly go through it, and there shouldn't be too much that's actually new for you. Now there's a whole variety of ways of detecting nuclear radiation. We have the fluorescence techniques, which basically rely on the light being given off when beta or gamma radiation excite atoms, alpha to a less extent. Basically they're looking at light being given off as a result of radiation particles exciting atoms. Photographic plates have always been used for a long time. Electroscope, which we'll look at shortly, Geiger-Müller counters, which hopefully in physical science you got a chance to use as well and learn how they work. Cloud chambers and bubble chambers and spark chambers. One way of detecting, if you have a radioactive source, you sometimes want to separate it into different or identify whether it's alpha, beta, gamma, or separate the alpha, beta, gamma. And we can do it in a variety of ways. We've seen how to do it in mass spectrometers, and this is basically a recap. In this case they're using an electric field to separate them, but we could use a magnetic field as well to separate them. Now this is an electroscope. Basically it's a pretty old school way of detecting radioactivity, and it was a way of just showing that certain types of radiation is actually charged and therefore is ionizing, because it's being an electroscope, it's all about building up charges, and basically the ionizing radiation charges this plate here that causes a little leaf, either a gold leaf or something very light, to rise up, and therefore you get an indication that particle or sample is radioactive. The cloud chamber, which is quite a fiddly piece of equipment to get to work, but there are some videos I think on the OneNote that show some bigger ones at some science museums that work quite well. Basically you have dry ice down here, so it's very cold. You make this chamber super saturated in alcohol, and then you have a radioactive source, and the little particles go through and they basically form a vapor trail behind them, and so you can see where the particles have been. So have a look at the videos of that, and if you haven't seen them already, just check them out. Now the Geiger counter, we learned how that was working last year. Basically you have an evacuated chamber with a very thin, usually it's made of thin metal or has a very thin end to it, which is only a foil, but it's evacuated and then the gas is put in there at low pressure. The radiation comes in, causes ionization. Now if that was just a normal tube, nothing would happen, you'd just get a bit of ionization and the current generated would be so small. However, within this tube they've actually got some plates and a central wire, which has a large potential difference across it, so there's a strong electric field, so any ionized gas particle gets accelerated, you get more collisions, and therefore you get a cascade effect, and therefore you get a blip of current which can be recorded as radioactivity. And that's basically how a Geiger-Müller counter works. This is a picture from, it's not a cloud chamber, a bubble chamber. Yes, that's probably a better way of saying it. And here's lots of complex interactions between subatomic particles occurring, and there's an overall magnetic or electric field being applied, and therefore some particles are going in spirals because they're actually slowing down. If they weren't slowing down, they'd go in circular motion. And you can see lots of things happening here. But there will be a video of a cloud chamber and various other things on the OneNote, so have a look at those. Badges are worn by people who are working in radioactive areas. They basically look like this, where you put a photographic film which is sealed in thin plastic so it doesn't get exposed to light, even though it's photographic paper. Means you can open and close it and take the film out and send it off to be developed. And then your badge has these different layers of different thicknesses and different materials, and so when you get your piece of paper developed, you can see what sort of radiation dosage you're getting and even what type of radiation it is. And it's a sample because you wear it on your body and it only represents a small amount of your body, but it gives you a good indication of what's happening. So you will see people wearing these or variations of these if you ever go to the nuclear physics section of a hospital. Let's see, and that's what they look like, variation of them. And in the next video we'll also be recapping something we mentioned in physical science, but we'll go in a little bit more detail, and that's nuclear stability. See ya.